Here you can see the schematic of Wheatstone bridge. It has 4 resistive arms with the different resistors R1, R2, R3 and R4. We can see that there is a EMF source, that is nothing but a battery. It is known as E, which is giving a supply to this circuit, and there is a galvanometer G. So this is also known as null detector. So when the bridge is balanced, the voltage or the current through this galvanometer will be 0. So at that time we will say that the bridge is balanced. So that is the working principle of a bridge, Wheatstone bridge, and you can see that different currents I1, I2, I3 and I4 is flowing through this circuit, and there are 4 points marked in the circuit A, B, C and D. So consider there is no current flow through the galvanometer. Then the current through this path is through the galvanometer is 0. That essentially means that the potential difference across this galvanometer is 0. That means potential difference across C and D are equal. So if the potential difference across C and D are equal, we can write like this: VAC is equal to VAD. So that means the potential difference across the path across this arm must be equal to the potential difference across this R2 arm. So what is VAC? VAC is the current flowing through AC into the resistance. What is the current flowing through AC? That is nothing but I1. So I can rewrite the equation like I1 into R1, which is equal to VAD. What is VAD? The current flowing through this arm into the resistance. That is nothing but I2 into R2. I will call this as the equation number 1. So consider there is no current flowing through the galvanometer. So we can cut this path, and that means that see here I1 is coming to C and it is dividing into two paths. So but since there is no current flow through this path, we can see that the entire I1 is flowing to this path CB also. So I1 must be equal to I3 since there is no current flowing through the galvanometer. Here also you can see that I2 must be equal to I4 since there is no current flowing through the galvanometer. So we can write that equation also: I1 equal to I3, which is given by what is the current flowing through this ACB. What is the current flowing through ACB? That is nothing but we can calculate like current can be calculated like VACB divided by what is the total resistance in that path. That is nothing but R1 plus R3. So VACB, what is the potential difference across this path? That is nothing but E. So instead of VACB, I can write like E by R1 plus R3. Now consider the other path. There we can write the equation like I2 is equal to I4, which is equal to VADB, that is VADB by R2 plus R4. So VADB is also equal to E because that is parallel path. ACB and ADB are parallel path. So we can write it like E by R2 plus R4. So I will call it as equation number 3. So why we have derived this? Because we can substitute this is the value of I1 and this is the value of I2. We can substitute this I1 and I2 in equation number 1. So I am going to substitute this I1 here and this I2 here. So I am going to substitute I1 and I2 in the equation number 1. So we can rewrite the equation like E R1 by R1 plus R3 equal to E R2 by R2 plus R4. This is R4, and we can see that E and E are common both the sides, so we can cancel it and we can rewrite it. I am just cross multiplying, so I will get R1 into R2 plus R4, which is equal to R2 into R1 plus. So if I multiply inside like this, I can essentially get like R1 R2 plus R1 R4 equal to R2 R1 plus R2 R3. So here also you can see that R1 R2 is present in both the sides, so I can cancel it. So the final equation will be R1 R4 equal to R2 R3. So that is the final equation. So that means what is R1 and R4? You can see that R1 and R4, R1 is here and R4 is here. So product of the resistance of the opposite arms are equal. Product of the resistance of the opposite arm are equal. You can see R3 here and R2 here. So I am just scrolling down. So we can write like product of resistance of opposite arms are equal. So that is the important formula about the Wheatstone bridge. And consider a condition where one of the resistance is unknown. Consider R4 is unknown. So in that case, I will call R4 as Rx. So I will rewrite like R1 Rx is equal to R2 R3. So from this, what is Rx? We know that Rx is equal to R2 R3 by R1. So if we know the three other resistances, we can find out the unknown resistance. That is the another application of Wheatstone bridge. Using the three known resistances, we can calculate the unknown resistance. So here one more point I have to add. That means the amp R3 is known as the standard amp. Arm R3 is known as standard arm, and the arms R2 and R1, these two arms R2 and R1 are known as ratio arms. And we have just seen that R4 is the unknown resistance.